Hello to everyone. The objective of today's video lecture is to elaborate on buffers. Today I will discuss what are buffers, classify them, and emphasize on some of its important or ideal characteristics. So, in a more simple way, or in a more simple term, we can say buffers are the solution which prevent change in pH. That is, these solutions helps in maintaining constant pH. Now, how a buffer solution maintain constant pH? This question can be answered by emphasizing technical definition of buffer, or by knowing the constituents of buffer. So technically, buffers are the solution, or we can say buffers are the mixture of solution which contains weak acid and its salt, or weak base and its salt. So the weak acid and its salt, or weak base and their respective salts, are the core ingredient which mechanistically helps buffer to maintain constant pH. So now it is a bit more clear to us that what ultimately the buffers are and how they helps in maintaining, or what the ingredients in buffers are helps to maintain constant pH. So before moving further, I here again define the buffer as buffers are the mixture of solution which contains weak acid and their salt, or weak base and its salt, which helps in maintaining constant pH, or which mechanistically prevents any change in pH upon addition of acid or base. So as I said earlier, that buffers prevent change in pH. So does this means a buffer can control pH at all quantity of acid or a base, or whatever the amount of acid or a base if added, buffer can resist change in pH. Now theoretically this must be true. However, in a practical sense, this is uncommon. So, practically, a buffer can only prevent or can only control the shifting of pH to certain extent of addition of an acid or a base. Ideally, when a small quantity of acid or a base is added to a buffer, it will maintain a constant pH. However, beyond that particular limit or beyond certain limit, the buffer is unable to maintain constant pH. On the basis of composition, a buffer can be classified as acidic buffer, and basic buffers. So, a buffer is said to be acidic if it consists of weak acid and its respective salt. For example, a buffer is said to be acidic if it contains acetic acid and sodium acetate, where the acetic acid is weak acid and sodium acetate is salt or sodium salt of weak acid. So this buffer is said to be acidic buffer as it contains weak acid and its respective salt. The overall pH or the net pH of acidic buffer is less than 7. Likewise, a buffer is said to be basic buffer if it contains weak base and its respective salts. The net pH for basic buffer is greater than 7. So, buffer constituted by ammonia and ammonium chloride is said to be a basic buffer, as it contains basic ingredients, and as per the definition, of basic buffer, it have weak base, that is ammonia, and its respective salt as ammonium chloride. Now let us see what are the ideal characteristics of buffers. So, an ideal buffer should possess characteristics which I am going to discuss now. Ideally, the very first characteristic of a buffer is to resist or control any shift in pH upon addition of small quantity of acid or base. So ideally, whenever a small quantity of acid or base is added to a buffer, it must be able to prevent any change in pH. Now chemically, the buffer should be non-interacting. This means whatever the constituents are used for the preparation of buffer, they must not interact or chemically interact with each other. Also, the constituents of buffer should not induce or promote any unwanted chemical reactions. Because if this happens, this will cause instability or chemical instability to the buffers. Purity is also considered as a paramount important characteristic of buffer. An impure buffer is of no use, or a buffer containing impurity cannot be used for the purpose whatsoever, or whatever is purposefully it is required, because the impurities present in the buffer or an impure buffer will impart toxicity as well as chemical instability to the buffers, because the impurity whatever is present may interact either with the buffer constituent or the impurity may interact with the system for which the buffer is used, and hence may impart some side reactions or chemical instability. A buffer should have long shelf life and it must be non-toxic. Long shelf life of a buffer helps it to preserve or store for longer duration of time. And if a buffer or any chemical which once prepared and can store for a longer duration of time, it is industrially preferred. Because such chemical or buffer or production of such chemical or buffer is cost effective from its production to end use or end users. Now, if a buffer is non-toxic, it can be easy to handle. Also, such buffer is free from causing any toxic effect or adverse effect on the person or the analyst technically using it. Ideally, further, the buffer should be easy to prepare, good to handle, can be stored as well as transport longer distance, without any deterioration. Also, it must be stable at wide temperature range. And the capacity or capability of a buffer to maintain its stability at wide temperature range will be good for its storage and transportation. Further, production of buffer or dispensing of buffer at small as well as large scale must be cost effective. Also, wherever required, it can be prepared, or can be purchased without any hindrance or restriction. That is, it must be easily available whenever required.